All right. Today's focus, different compound probabilities. How do we find the likelihood of two or more events happening at the same time? A couple different ways we can describe two or more events with our probabilities. We have to first know if the two events were independent or dependent. If two events are independent, the likelihood of one event has no impact on the likelihood of another. I've got two things happening at the same time, event A and event B. Does one affect or impact the other? If the answer is no, they are independent of each other. When I flip a coin and I get a heads, what's that probability? 1/2. I flip it again. Does the probability change based off of what I got the first time I flipped it? No, because flipping the coin twice are two independent events. Getting a heads the second time is not impacted by whether or not you got a heads the first time. That's a good example for independent events. The multiplication rule for independent events reads like what's down below here. The probability of A, that upside down U, is read as either and or intersect. This is notation in set theory or and. The probability of A and B occurring together is just the probability of the first event times the probability of the second event. If I flip a coin twice, I want to know the chance of getting heads and heads. That's just 1/2 times 1/2 or 1/4, because flipping a heads on the first coin, the second coin, two independent events. Just take the two probabilities and multiply them together. That's independent, where the outcome of one has no impact on the outcome of another. What if that's not the case? Rather than independent, we could have dependent events. In dependent events, this is where the outcome of one event affects the outcome of the other, or the likelihood of the others. Probability of what happens after the first event depends on whether or not you succeeded from the first event. The outcome from one event impacts the likelihood of another. The probability of what happens in event B is impacted by what happened in event A. So the probability of A and B is the probability of A times the probability of B given A. This is read as given. It's the probability of A times the probability of B, given that A has already happened. If I already know that A has happened, what is the probability of B? Because since B depends on A, the probability of B depends on whatever happened in the first event A. So given that A has already happened, what's the likelihood of event B? Because A impacts B, because B depends on A, I have to use that conditional statement to find the probability of A and B together. Questions you guys have so far? That upside down U means and. Another way to say the word and in mathematical or probability notation. You could say this as A intersect B. You could say it as A and B. It means the same thing. What's the probability of A and B? A couple different ways you can do it based off whether A and B are independent. If they are, just multiply the two probabilities together. If they are not, you have to think about how the probability of B changes based off of what happened in event A. All right. Let's try this first one. I'm going to read through this question. You tell me if this is independent or dependent. If it's independent, what happens next has no impact on what happened the first time. If they're dependent, that's not the case. In a bag of Starburst, 35% of candies are red, 30% are orange, 25% are yellow, and the rest are pink. You reach in and pull out 3 candies, one at a time with replacement. What is with replacement? Put it back. I replaced the candy I took out and I put it back in the bag. Find each probability. Would this be an independent scenario or dependent?
Dependent.
Does what I pull out the second time, is that dependent upon what I pulled out the first time?
Yeah.
I put it back. So is it still the same bag that I'm drawing from the second time or when I drew from it the first time?
Yes.
So is it independent or dependent? Independent. The second draw is not impacted by what I took out the first time. What told you that? The second draw is not impacted by what I took out the first time. What told you that?
Replacement.
With replacement. Because I put it back, each next draw is not dependent upon the first draw because it's still the same bag you're drawing from, right? Right? How many candies do I pull out? How many candies do I pull out? Three candies. I take out 3 candies. I've got all sorts of different probabilities for us to find. In the first one, I want them all to be orange. So what do all 3 of my candies look like? They're all orange. I want orange, orange, and orange. What is the probability of pulling out an orange?
All, just one orange?
Just one orange. What's the proportion of the candies in the bag that are orange? Right? So I take out the first orange. It's 30%. I put that candy back and I draw again. Since it's independent, what's the probability of getting an orange the second time? Still 30%. The third time, still 30%. What do I do with these 3 values? What's 0.3 times itself 3 times? 0.3 to the third, in other words.
0.027.
0.27. That about a 3% chance of pulling out 3 orange candies from the bag. How about number 2? I want no yellows. I take 3 candies out. What do I know about those 3 candies?
Not yet.
They can't be yellow. I like to write it out. No yellow, no yellow, no yellow. Now I'm going to find the probability of taking out no yellows and then just do it 3 times, right? Because it's independent. It's the same bag each time. I can just multiply the probability from event 1 times itself 3 times. What's the probability of not getting a yellow?
75%.
How'd you get that, Michael? It says 25% are yellow, Michael. So what percent is not yellow?
75%.
75%, right? If 25% are yellow, wouldn't just everything else be not yellow? So it's 0.75 times another 0.75 because it's independent. Times 0.75. Or you could do 0.75 to the third. What do we get here? About 42.19%? About a 42% chance you get all 3 candies not yellow. Okay. Part 3, 2 red and a pink in any order. 2 red and a pink in any order. So I take 3 candies out. What do I know about those 3 candies? 2 of them red and 1 of them's pink. I want to do red, red, pink. Red, red, pink. What percent are red? Okay, 35%. Times 35% for red the second time. I want to pull out a pink. What percent are pink?
3.
It said the rest are pink. 35% are red, 30% are orange, 25% are yellow. What's left over for the pinks? 35 and 25 make 60. 30% for the orange So 10% for the pink? Now it said in any order. Do they have to come out red, red, pink?
No. Certainly not. Pink, red, red,
Pink, red, red, or,
red,
Red.
pink, red.
so aren't there 3 ways to do it?
Yeah.
I'm gonna multiply by 3 choose 2, because I have to know how many ways there are to get the 2 red candies from the 3 I'm taking in. What is 3 choose 2? From the 3 candies I select, how many ways can I select 2 of them with red? 3, because aren't there 3 ways that this could be done? It's the probability of it happening times the number of ways it can happen. It says in any order. I don't have to pull it out as red, then pink. Like you said earlier, couldn't it be red, pink, red? Or pink, red, red? I take the probability of it happening times the number of ways it can happen to give me the final answer of doing this in general. So I need 0.35 times 0.35 times 0.1. That's 0.01225. Times what? 3. Here's the probability of doing it one way, but it can happen in 3 total ways. Let's just take that times 3. About 0.03675. I have one more in mind before we try the deck of cards again.
Claire Newell, please report to the secondary office. Claire Newell, report to the secondary office.
Okay, the last one says at least 1 orange. We've used that phrase before. In last week, how did we think about at least 1? What does that mean? You have to have 1 orange, or
No orange.
you can't have no orange. At least 1 and none are different.
That's not
1, 2, or 3. I just can't have. So I like doing this a little bit backwards by thinking about, like you said, Brooke, as at least 1 and none are just opposite. If I take the total probability and subtract off what I don't want to happen, wouldn't that leave me my answer? So let's take what everything has to add up to, 1, and subtract off the no orange probability. Everything has to add to 100%, or 1. If I subtract off the probability of no oranges being drawn, what that leaves over is at least 1. The answer I get will be the probability of having at least 1 orange in my hand. So 1 minus. What percent are not orange? 70%. You get 70% though. Yeah, 30% are orange, so 70% are not. I need 0.7 how many times? 3, because I'm taking out 3 candies. .7 to the third, it's 0.343. One minus 0.343. There's a 34.3% chance of getting no oranges. So if I take 100% minus 34.3%, what's left over should be the probability of at least 1 orange. Subtract away what you don't want to happen. What you're left with is your answer. Almost 2/3, 0.656. What are your thoughts here, guys? Okay. Let's try another couple of scenarios here. I'm going to read through this statement. You tell me if it's independent or dependent. Rather than candies and Starburst, now we're doing decks of cards. 3 cards are drawn from a standard deck, one at a time without replacement. What does that phrase without replacement mean? I don't put it back. Take a card out, I put it aside. I don't put it back for the next draw. Find these probabilities. You can tell me independent or dependent. Why dependent? How?
Because you're not replacing.
Right. So each time I draw from it, wouldn't the next time I draw be a different deck that I'm drawing from?
Yeah.
So the likelihood of what happens next is impacted by what came before. Because we're selecting without replacement, this is a dependent scenario. What happens next, the probability of that, depends on whatever happened first. Okay? I've got a couple different scenarios here. I'm going to try one together as a class. I'll leave the next 3 for you to work on, and we'll go over your answers together. I want to get all face cards. I want to get 3 straight faces. The face cards are in the deck.
Oh, wait.
How
That's all
many
cards.
face cards? There are 52 cards, but of those, how many are face cards? Which AJ? 12. So of the 52 cards, all of them are faces. Okay, took that face card out, I put it aside. I want to get a face card again. How many cards are there to draw from? There's 11 face cards from how many cards in the deck left over, actually? 51. Why did I go from 12 to 11 and 52 down to 51?
Because you weren't putting them back.
I lost the card. I didn't put it back. I selected without replacement. If this was independent, it should still be 12 out of 52 here. But because it's dependent, what I did the first time affects the outcome of what happens next. That's why this number changes over there when it didn't over here. Okay, I need to get one more face card. I gotta have 3.
So 10.
Out of 50. I didn't put that second face card back in the deck, so there's one less face card to draw from, and then one less card in the deck in total. So let's type that into Desmos here. 12 over 52 times 11 over 51 times 10 out of 50. 0.001, roughly. About a 1/10 of a percent. Okay. You've got the next 3 to look at. 3 cards, no clubs. 3 cards where the last one is red. And the 3 cards you want at least 1 king from. The deck of cards is right behind you. I've got hearts, diamonds, spades, and clubs, all broken down from your range. There's 4 suits and 52 cards in total. So 52 divided by 4 says there's 13 cards per ace. Ace through king is 13. Let's take about 3 or 4 minutes. Would that be enough time to try these 3? Let's do it. Up on the screen. I kept those 3 ratios in. And this is the number the calculator gave to me. It's about 0.001 if I round up.
So I saw you mowing the lawn. At that
What
one.
can't happen? What takes no more than is probably getting no more, you know, it's factor 1.
Dude, it was so obvious. You were, I could tell. Also went like 100.
0.7.
Just-
No, like, I can that.
Okay. What percent are orange? What percent are
Maybe not food. Okay.
30% are orange. The other 70% are not. percent drawing. No
Come
more.
on.
I do that.
It's,
41.
41.
Here,
No, oh, sorry.
Oh, yeah.
Okay, but if it's 39, wait.
Last card is red. What do we get with the first two cards?
You don't want clubs.
And then 38.
So black.
Oh,
Black, black, red.
Okay, so.
Doesn't go
It helps you write it out.
No clubs. No
Because if I do like
clubs.
no yellow, no yellow, no yellow, it might help you
And so
diagram it
you're
out.
drawing one from each
Black.
thing, and you're not gonna be putting them back.
How many cards in the deck are black?
So it'd be 39 on the bottom, if you did it in math, right, honestly, I don't know what one on the back end is, but.
Dude, why do you keep getting most of that? That's how.
I don't put it back. It's dependent.
I don't know. I don't know.
I don't know, sword.
25.
Well, shit, it should have been.
Now the red. How many cards are you drawing from? I haven't taken a red out. 26 out of 50.
Oh, out of 50?
I get the red card last. I take 2 cards out first.
Oh, you're on the third one.
Yeah.
Wait,
I
so
was
it
on the
doesn't,
second one.
but it doesn't say anything about the other two cards.
Last one is red. Okay, let me rephrase it here. Last card is the only red.
Okay.
You're right, like I should rephrase that.
I really should.
Last card is the only red.
Give me a start there.
Yeah.
So there's 30, oh no, there's 26 reds.
Yeah, no, it's also just.
Out of 20 plus.
That's what I was trying to say earlier. Sorry about the confusion there. Does that make sense now?
Yeah.
The last card's the only red. The other 2 cards are
26
black.
No, it would be 20. So I should come out.
I should go there instead of church on Wednesday.
No.
I might be going to church.
Wait, do they?
We're gonna go over these in about 2 minutes, guys. Are you ready?
Yeah, you can do that. You can order it to go, and then you can pick
That might do that on yours.
What are you guys talking about?
it.
Dude, I thought that was.
Sure, you got all these written down?
No, I definitely.
Okay. Well, then there's no time like the present, sir.
That's so far.
I want to see.
Oh, yeah.
Time like now.
Yeah, we
Mark, you ready to go?
We did some substitutes.
Mark, Blake, you ready to go, sir?
Actually, Barker.
Ellen, ready to go?
Okay,
These right now. No clubs is up first.
Okay, so.
Okay, so I get it. I'm just curious because people were talking about this finish. We're gonna move on.
Wait, Mr. Hanson, I have a question. Sorry, I'm so confused.
What's up?
Okay, so for the no club one, not out of like all cards, like all 52?
Yeah.
Okay, that's what I
You
thought.
start from a standard deck, but then you draw without replacing. So you don't put the first card back before you take the second card out.
So it would be like 39 out of 52. Okay, that's what I thought.
And then if you draw the next card, how many
It'd be
cards are you
38
gonna draw
or
from?
51.
Correct.
Got it. Okay. I'm interested.
Oh,
I want a little older girl.
don't some have like.
I wanna get a
Okay,
pin-up-
that first one, then. Now we try number
I
2.
wanna get a pin-up girl.
No clubs.
I'm scared.
That's the back one.
20,000.
Three nice cards.
And that was a 20 million.
Okay. That's the first card. I'm gonna do it again. I need 3 cards.
It's 1 million. It keeps 9.
I don't put it back. Good. 37 over.
Every time you do this, you should make it as an abuse.
What is low easy birds?
I had the 1 minus, right?
Yeah.
I'm just big.
No clubs. How many cards aren't clubs?
16 million.
16.
Yeah, that means he would have had to have what?
He's been thinking about
36 million.
You make money on that. So how many cards in total?
Just tastes like vanilla Oreos. I got them in the
He's still paying.
Now, the next time I draw a card,
I don't even like, you like what we normal.
What are my favorite cheeses?
Here, guys, how we doing?
Yeah.
No, I think we'll get those cards. I have another thing. Tomorrow's early out.
Oh, yeah.
Early out tomorrow and again on the
And today.
Thursday, we have a master.
I'm gonna go do that.
I just won't be in math.
Last card's the only way.
Ashton, maybe.
1 minute warning. 1 minute warning. Questions, guys? Something help you?
Oh, unless you want to.
We'll go over these in just a second.
Like,
For number two, let's do it. Try the next one. 1 minute left.
yeah. Okay. It's the same thing, I just continue. Use that one.
You know what looks better? Basic. Easy. Okay. It's hard to write something down if you're not using it.
That's not true. It's hard to listen if you're not writing.
Questions over here, Chief. Good job.
So if there's 26 red cards, there's only 26 left.
What are you talking about?
Okay, well,
Which one are you working on?
I'm showing,
You set up number 3?
yeah, last card's only red.
Yeah, so the first two cards are both what?
No, not red.
Blacks.
What?
Black, in other words, yeah.
Oh, yeah,
Wait, is it like supposed to be non?
I don't run it. No.
Generally, hard.
Okay, let's get started.
I'll wait. Help me.
No clubs.
The engineering.
Parker, how many cards aren't clubs in the deck? How many cards are not clubs?
39.
39 sounds right. So for the first card, 39 out of 52 is the probability of not getting a club. Don't put it back. Think about how many cards are in the deck the next time I draw.
38.
Good. There's one less club to draw from. There's one less card to draw from in total. Last time, isn't it just 37 out of 50?
Yeah.
Let's grab my calculator here and we'll get that typed in. 39 of 52 times 38 of 51 and 37 of 50. 41.35%. Let's try number 3. Last card is the only red. So what do the first two cards look like, Bill? The last card is the only red. What happens the first two draws? Not quite, because the other two cards were just not red, yeah? In other words, they're both black. Black, black, red. How many cards, Dylan, are black in a deck? 26 of 52, or a half, like I think you said a second ago. I don't put the card back, so now it's 25 of 51. Why is it 26 now again? After? Guys, I can't hear. It's red. Have I taken a red card out yet?
No.
No, so there's still the 26 red cards left in the deck that were there to begin with,
Then they're
but there's only 50 cards because I didn't put the first two cards back. All right, we're going to do 26 of 52 times 25 of 51 times 26 of 50. About 12.75%.
Yeah, I got double.
At least one king. Once again, what makes this one more difficult, Maddie? At least one king means what?
Oh, that you can have one or
1 through 3 kings. I just can't have what happen?
Zero.
No kings. So let's take everything, 100%, whatever you want to call it, and subtract off what I don't want to happen. If I take away the opposite, what is left over should be the probability for my answer, having at least 1 king in my hand. No kings. How many cards aren't kings, Trey?
Well, would be 48.
48, because there are 4 kings. The other 48 are not. So 48 of 52 times what?
47 over 51.
All right, Hallie gave me that. And then we see the pattern now, 46 out of 50. Let's just type it into our calculator, just like you see it up on the screen. 1 minus 48 of 52. 47 of 51. And 46 of 50. What's that here? About 21.74? Roughly a 20% chance you'll have at least 1 king when you pull out 3 random cards. All right, look at your answers. Look at the board. Check your work. What questions are you having here so far this morning? These 4 answers. Look at your work that you just finished up. Questions, thoughts? Where's the disconnect coming from? What can we talk about still? They're still giving us some issues.
Specifically, number 3, like when do we introduce the PCR?
You see where it says in any order?
Yeah.
Order doesn't matter. It could be red, red, pink. It could be red, pink, red.
Yeah.
It could be pink, red, red. When you see the phrase in any order,
Yeah.
Stephen, then you're gonna have to use a combinatorics because it can happen in more than one ways.
So and like we only chose 3 choose 2.
3 choose 2 because I have to know the number of ways to pick
2.
which 2 candies need to be red. It's 3 choose 2 times 1 choose 1 because once you pick the 2 reds, there's only 1 left over for the pick.
Oh,
So
so
1
it's,
choose 1 is just 1.
so it's not like choosing the number of candies into the number of spots. It's like the number of candies already there.
Yes. Once you know you have to have 2 red, how can you assign 2 red to the 3 you draw?
Yeah.
Different.
How far should we be?
Okay, like I said at the beginning of class, at the end of the week, you're going to have it done. You should be down through quiz 2 with the goal we set last.
No, never mind, you're right.
I kind of think that what's on time and week by week increments. Through quiz 1 after week 1, through quiz 2 after week 2. This is week 3, so you're on up. All right, guys, I'm passing out some practice here. Let's take the last 5 minutes of class today and tomorrow. Working what's on here. Yep. Gus, I'm going to share my screen with you here.
Is it supposed to stop?